And last but not least, let's see what happens when we increase the sample size. So now our sample size n is going to be 1500 instead of 150. The sample mean and sample standard deviation are as they were originally. We're going to compute our 2SD confidence interval with the same formula. X bar, the sample statistic, plus or minus 2, times the standard deviation of the null distribution, which is the sample standard deviation S, divided by the square root of the sample size. Again, the best thing you can do for yourself is pause the video and work through this calculation for yourself. If we take the sample mean, 2.23 plus or minus 2, times 1.05, the original sample standard deviation, and now dividing by the square root of 1500, so I've increased my sample size. So when I do that division, I get 0.0271, and then I go ahead and multiply that by 2 and get 0.0542. And let's just make note that that is the margin of error. So compare that to the margin of error that we just did in number 19. They are different by a factor of 10, and my sample size is changed by a factor of 100 from 15 to 1500, and that has caused my margin of error to go down by a factor of 10. That's very interesting. Might want to think about that later. Okay, then I'm going to do my plus and minus. So I put the subtraction on the left. I take my statistic minus the margin of error, and then on the right I do the statistic plus the margin of error. And I come up with my interval limits. When you do the subtraction, you should get 2.1758. When you do the addition, you should get 2.2842. So you have created the confidence interval. Let's go ahead and find the midpoint, where we take the high value, 2.2842, and add the low value, 2.1758. After that addition is done, I divide by 2, and lo and behold, yet again, the midpoint of my confidence interval is the statistic, in this case x bar, the sample mean of 2.23. I can also find the width of my interval by taking the high value, 2.2842, and subtracting the low value, 2.1758. And when you do that, you should get a width of 0.1084. Which again, if you compare to the previous width, it's the previous width divided by 10 gets us this new width. And then, just for good measure, the margin of error I can get by taking the width and cutting it in half or dividing it by 2. So if you take 0.1084 and divide that by 2, you will get 0.0542, which is the margin of error that we saw as we were computing the confidence interval. Okay, so let's see what happened. My original sample size was 150, and the width of my confidence interval was 0.343. Now I have increased my sample size to 1500, and the width of my confidence interval has gone down to 0.1084. So my sample size went up, increased, and my width went down. So this is what I was starting to say before. Let's go through it. When your sample size increases, that decreases the variability or standard deviation of the null distribution. So the S over radical n has gotten smaller when I've increased my sample size. And when I decrease the variability in my null distribution, that decreases the margin of error on my confidence interval, which in turn decreases the width of the interval. So, sample size has gone up, width has gone down. Now, for a quick recap, and you might want to take some notes on this for yourself, we've looked at three things that influence the width of the confidence interval. One is the confidence level. When the confidence level goes up, the width of the interval also goes up. Or you could look at it the other way. If the confidence level goes down, the width of the interval will also go down. Then we looked at sample standard deviation. If the sample standard deviation goes up, so does the width of the interval. Or if the sample standard deviation goes down, then the width of the interval also goes down. And last but not least, we looked at sample size. If the sample size decreases, then the width of the interval increases. Or if the sample size increases, goes up, then the width of the confidence interval decreases.